What are we doing? Is this the user group meeting, I think? I'm so tired. Yesterday, I think, went very, very well. I'd love to have feedback from anybody, either in Slack or in person or email or whatever, but you know, we do this for you guys, and we want to make sure that the time, the length of time that we give for talking, the length of time we give for eating and talking out there and drawing pictures with each other are good and have a good balance. We had the largest number of talks this year that we've had ever, and so I had a logistical situation and trying to fit everybody in and make sure everybody had enough time to talk. But I feel like yesterday was a good balance. If that's not what you feel, then please let me know and we can adjust accordingly. Maybe not today, but maybe the next time we do this. In terms of administrative things, I don't think we have too terribly many updates to give. T-shirts, obviously, if you're still in a situation with your T-shirt, we can fix that for you. And the contact list for all of you is now in Slack, so you can find a link and find each other. Is anybody having trouble getting into Slack? If you need help, find a friend. Yes, find Steph. I think we are ready to go. So we have, I think, a series of 3 talks this morning. 1, 2, 3, 4, because I can't count. We'll have a break, and then we have 2 more before lunch, and that's as far ahead as I can think. So the first talk today is not by Christian, but rather by Navya. This is Navya. She's going to be talking about our iRODS, platform-independent R package connecting open source data management software along with a metadata explorer at Bayer Crop Science. This is also on.
Okay, thank you. Hello, everyone. So I'm Navya from Tata Consultancy Services. And today I'm here to present about data management and analytics solution that we have done in collaboration with Bayer Crop Science. So here below you can see our team who have worked on this collaboration. And so primarily having huge data nowadays, so we have the digital farming department at Bayer Crop Science, which primarily deals with crop science data. And starting with the data as such, so we were working on very huge sets of data, and there was a very emerging need to have some kind of data management platform. At the same time, we also wanted to offer some kind of data analytics in order to handle such big data by offering interaction and integration with our clients, as well as some kind of a web interface to have the data visualization and other statistical modeling. So, so where do we start? So primarily we were handling huge heterogeneous crop science data. So the digital farming department there was dealing with different kinds of data files, which were very diverse. So we had CSVs, JSON, then shape files, and projection files, DBJ files, so which were offered from various different applications primarily. So we were also handling different data file formats from AutoCAD and other Visual Studio softwares. So there was every need to have this data which was from remote locations, which was distributed, which was heterogeneous, which was primarily unstructured, and we wanted a way also to tag metadata to this so that we could better handle the data and also deliver the data access in a more easier manner. So primarily, most of these files were image files. So the major reason for choosing iRODS as a solution for these kind of data is we wanted to have some kind of handle on the metadata, and also for annotating the various kinds of data. And then we were also offering some kind of audit reporting and also audit tracking and various access control lists. And we were having different user groups having read access, read-write access, and only write access, no delete access groups. So we were having different farmers having different groups. At the same time, we were also ensuring that we have rule policies that enforce checksum for every data being injected. And also we ensured to have some proper kind of replication between the data being stored in different copies, as well as the performance too, by handling the data being downloaded in time. So what was the primary motivation for this data management and analysis solution? So we had different crops located, distributed across geographies, and primarily they were unstructured data, and we thought iRODS is the one solution which could offer an open source platform. At the same time, we could handle the metadata. So then, now we had the data into iRODS, and then there was the issue with the data analysis and also some complaints from the researchers as well as the data analysts. So they were handling all the downstream processing of the data. Once they have the metadata as well as the data search based on the metadata, there was every need to analyze the data. So they were using RStudio as a platform for the various data analysis and also to analyze the study trends, or even to analyze the quality of the images that we were using in the applications. So most of these farming applications and the digital farming utilities were using RStudio as a means for the analysis, and we wanted every need to access the data and iRODS into R. So we want to pull the data from iRODS into R, then process the data and write back into iRODS. So there was no easier way to directly access the iRODS data into R, and this was the reason why we have come up with this open source package, which is platform independent in Linux as well as tested in Windows. And it has also the support for all the I commands. So all of the I commands that we have in iRODS are now supported via RStudio. And then later on, we also wanted to have some kind of quality analytics. And for this, we have developed a Shiny-based web interface using iMeta Explorer. So now, to start with this package as such. So initially, I think I would say thanks to Mike for offering the iRODS REST API, which is very powerful and also extensible. So we have also extended most of these web services, these REST services, come up with some custom endpoints in order to enhance the features for all the metadata CRUD operations, as well as accessing iRODS via RStudio. So this package was primarily started with R 3.1.1, so 3.3.1, and it also has the support for both Windows and Linux. So this is primarily a distributed package, and we can access any of the I commands. So all the I commands, starting with listing and also offering stateful navigation at the same time in order to add, update, or delete metadata. And we also have offered the facility wherein you can add or update or delete metadata based on a specific attribute or based on all attributes. And we also have come up with some custom utilities and add-ins that could help to provide custom metadata additions or even to perform any kind of bulk metadata operations. So for this, we have introduced Swagger. So we were using Swagger for the REST API for all the integration, where we had the R wrapper, and this was allowing to interact with the iRODS REST API, and then it was connecting to iRODS. So on top of this, we also had the search command. So similar to iQuest, we also have a search command which helps to search files based on metadata or search files by file name or any regex patterns. So here is the complete listing of the functions we offer as of today for the R packaging, if you see. So primarily the add, edit, delete are the common functionalities that we also see in I commands. In addition to this, we have come up with I pull all metadata and I pull custom metadata. So this is specific to the needs of the digital farming department at Bayer Crop Science. In addition to that, we also offer I delete all metadata by attribute name, which is quite addition to what commands we have in iRODS. So this is in order to delete based on a specific attribute name or even to update based on a specific metadata. So these are some custom tuned functions in order to handle most of the use cases that we have handled at Bayer. in addition to this, if we look back here, so there is also a necessity where we had to search files based on some training models. Now that we have various images into our backend and we wanted to quality tag the images based on some training models, so these functions were really helpful in handling most of the use case scenarios that we have had there. So now we had the package, and then there was this need to handle a web interface in order to perform the data visualization as such. So we have different kinds of users at our crop science department. We had the farmer, then we had the salesperson, as well as all the data analysts or researchers who were handling the data. So they were reading the data at the same time performing some downstream processing and writing the data back to iRODS. So we had a separate analytical component for analyzing the various crop models using R and Java, so which was directly interacting with iRODS using our R iRODS package. And we had the analytical data coming on a periodic basis. At the same time, we also had some training models that helped to periodically have updated data available on a periodic basis. We had a master database for the entire crop models that we were handling there, and we had every need to handle various services from the front end as well. So in addition to data visualization, at the same time, we also had features for metadata associations as such between the data. And we also offered some kind of a map view for the various data at various locations based on metadata search as well as based on the data. And we had few rule engine policies to define some metadata validations on the data that is tagged to the various crop files or the image files. And we also had a cloud visualization and tagging for the data. So this was using, again, the Shiny package, which was internally working on using our R commands within the Shiny application. And we had the powerful search features too. So looking in deep to the features that we had in this web interface. So this is our first version of the web interface, which involves the basic login, where we had fixed users and roles. It was a user-based login with a centralized authentication service. So we were also integrating this with Gigia authentication. And then we have the familiar file explorer view, where we have the tree view as well as the normal view, and options for upload, delete, download, move, copy, all the iRODS features that we see in cloud browser. And we also offer bookmark feature, and including the geo metadata, wherein we could also fetch files based on metadata and based on their geolocations, especially for the crops. And we also offer a few kind of metadata operations within this web application, where you can also perform bulk metadata operations for add, edit, and delete. So this is all based on the REST API services internally. Then we also had the need for a statistical modeling of the data. So this was where we wanted to have the feature with metadata associations. So wherein we were using some metadata rules in order to have the suggested metadata associations, and also a kind of network graphs to better understand this metadata and the interaction with the various files. So search was a common feature, which was both file-based search as well as metadata-based search. So if you look deep, we offered both multi-file search as well as a search by metadata, where you can search by the AVU, or you can also search by the file name. Then we also had the features for the cloud tagging. So for the entire application based on the federation or the zone, we could find a cloud tag here, wherein this way we get to identify what are the prominent metadata that is present within the entire data being monitored. At the same time, we also had the need to correct the data based on any misclassifications, if any. So this particular feature was very helpful in identifying proper storage of the data into the corresponding groups, as well as the various data classified models. Then we had this geometa tagging. So this was primarily to locate the various data from various locations, since we had distributed data across various countries. So there was every need to pinpoint the data, and also to locate what kind of image resolution was present to better qualify the data and also to perform various image analytics on the data obtained. So this is one good feature which is offered in this Shiny application, where you can easily locate the files and further add, edit, or modify the metadata present on any of those pinpointed locations. So in addition to this, the other primary feature where we offer in this Shiny application is the network association graphs. So this was the most crucial feature wherein there was heavy necessity to have the data and also suggested notifications for the metadata belonging to data of a specific type. So given a crop sensitivity or soil temperature, any such metadata related to any farming applications, there was every need for suggested notifications to notify the user for the upcoming metadata which could be added. So this was also one powerful feature which helps to identify some metadata clusters and also to group files based on some metadata clusters. Yeah, so these are the ongoing features and future topics. So with regard to the iRODS package, in future we also try to integrate with the CRAN so that we have a smooth and seamless integration with Bitbucket. At the same time also support with add-ins so that we could integrate with the upcoming versions of RStudio IDE. At the same time, for the web application, we are also trying to focus more on the regex-based search, as well as also extensive support for other visual analytics and to understand the study trends within the data or the metadata interconnected with it. Yeah, thank you. So if anyone has any questions.
Yeah. Ready?
It's actually very nice, thank you. I think, and also making very good use of the REST API. I'm really impressed that you're able to take the RStudio and integrate it very nicely with the system. Do you also store your R scripts in iRODS and then pull it as you need it, or do you have to store it locally?
No, we store it separately. At the moment, we don't find the heavy need to because we handle it internally via the CRAN packaging.
Okay,
Yeah.
okay.
I had a question about you're using Shiny for the web interface. Have you run into any performance issues
Yes,
related to using
definitely. So we initially had issues with the REST API directly. So we have used Spring Security and JWT based tokenization. So I think this saved almost 50% of our performance time here. Not at the moment, so this is highly internal. Yeah.
Anybody else? All right. Well, thank you.
Okay, thank you.
Find my agenda.